Hello, welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the lesson on proving trigonometric identities, and in this video I'm just going to be talking through the trig identities that you absolutely need to know and going through one example of applying this to proving another trig identity. So, trig identities. You need to know the double angle identities for sine 2x, cos 2x. You need to know the Pythagorean identities, that's the ones with the squares in it, and you need to know the tan and the cot identities. Okay, so double angle identities to start off with. Sine 2x is 2 sine x cos x. There are 3 for cos 2x, you need to know them all. There's cos squared x minus sine squared x. There's 2 cos squared x minus 1. And there's 1 minus 2 sine squared x. Now I always present them with the cos squared x minus sine squared x first, because you can use this identity to find the other two by first of all replacing sine squared x with 1 minus cos squared x, or for this one replacing cos squared x with 1 minus sine squared x. The other thing about these 4 double angle identities is you've got to know them backwards. So if you see 2 sine x cos x within part of your proof, you need to recognise that that's sine 2x, because often that will simplify your process of proving another identity if you can recognise that and make that adjustment. When I talked about the Pythagorean identities, I'm talking about the ones with a squared in them. So you would have all started off by learning that sine squared x plus cos squared x equals 1. There are 2 further Pythagorean identities. One is that tan squared x plus 1 equals sec squared x. And the other is that 1 plus cot squared x is equal to cosec squared x. And these two can both be derived from the first one. If you divide each term through by cos squared x, then sine squared over cos squared is tan squared, cos squared over cos squared is 1, and 1 over cos squared is sec squared. And the second identity can be derived by dividing through by sine squared instead. In addition to that, you need to not forget the fact that tan is sine over cos, and that cot is cos over sine. Oh, x's rather than thetas. Now, with all of these identities, if I replace the x with something else, say 2x, 3x, x plus 15, 2x minus pi over 3, anything like that, it replaces each x with that same function and the identity still holds. Right, so let's apply this to another proof then. We have to prove that 2 sec x equals cos x over 1 minus sine x plus 1 minus sine x over cos x. Now, a tip I always give to my students when you are solving problems like this is think about what your penultimate line is going to be. Think about what the second to last thing is going to be that you write before you conclude that it's 2 sec x. And in this case, because sec is 1 over cos, it's likely that your penultimate line is going to be 2 over cos x. And it's often much, much easier to aim at that rather than trying to aim at 2 sec x. So, what I'm just going to do then is I'm going to write out the right-hand side of this identity, cos x over 1 minus sine x, plus 1 minus sine x over cos x. And I'm going to try to manipulate this, and I'm aiming to get to 2 over cos x. Generally, your strategy with proving these trig identities is to start with the side that looks more complicated or has more terms and try to simplify it to the expression on the other side of the identity. So, 2 fractions, sum, I'm going to need a common denominator. I'm going to multiply both these numerator and denominator here by cos x. And for the second fraction, I'm going to multiply both the numerator and the denominator by 1 minus sin x. And that's all going to be over cos x, 1 minus sin x. Now, a tip at this stage. Look at what we're aiming at. We're aiming to get to 2 over cos x, and I've got cos x on the denominator. So for that reason, I'm not going to expand out the denominator, because what I'm hoping is going to happen is something on the numerator is going to enable me to cancel the 1 minus 2x part and leave me just with the cos. Let's see if that's what's going to happen. So I'm going to get cos squared x, and then expanding this out, we've got 1, that's going to be minus 2 sin x, plus sin squared x. And that is all over cos x multiplied by 1 minus sin x. Now, what can we spot here? What have we got on our numerator? Well, we've got cos squared x and we've got sin squared x, and we know that the identity is that sin squared x plus cos squared x equals 1. So I can replace that with 1, which when I add to this one is going to give me 2 minus 2 sin x on my numerator. And you may see that this is falling out quite beautifully here. Remember I said not to expand the denominator, we're looking for something to cancel. Look at the common factor you've got on the numerator here. Common factor of 2. So I can factorise that 2 out to give me 1 minus sin x, which is all over cos x multiplied by 1 minus sin x. And because I now have a common term on the numerator and denominator, I can cancel that 1 minus sin x with that 1 minus sin x, which gives me 2 over cos x which, as you remember, is what we were really aiming for, because we knew that 2 over cos x is the same as 2 sec x. And you can write QED. Technically stands for quod erat demonstratum. I prefer a former student's version, which was quite easily done. Remember though, key point, what we're aiming at in the penultimate step, aim for that rather than the final answer, and generally you can see your route through it more clearly if you do that. Join me in the next video where I'll go through one more example that leads to a little bit of solving afterwards as well.